Spectrum, Futaba, Frisky, they're all garbage. They're the reason I crashed. It's time for a pre-flight series. I've been working on this for months. I think it's finally time to get this finished. Here we go. Welcome everybody back to the channel. I'm Brendan. Thanks for joining me here at Just Plain Crazy. Hey, let's delve into why your maiden wasn't successful. Is it a UBEC failure? Is it a servo failure? Was it a battery failure? Was it those dreaded receivers? Whatever those things are, join me. I'm going to run through pre-flights with you, pre-flights in the basement before I ever get outside, and then pre-flights and glow models, pre-flights and foam models, pre-flights and glow models that use rubber bands. Yes, rubber bands. So I'm going to, as I go through this, each step of the way, a little bit of tips and tricks in each one. So check them all out as we go through, hang around with me, and you're going to pick up some things. What's a wiggle test? How do we do a wiggle test? I'm going to show you guys how to do a wiggle test and what that really means. Checking balance and different tips and tricks like that. So without much ado, let's get into this. So one of the first things, I got 26 different planes, all running in Spectrum. I don't know, 10,000, 5,000, 8,000 flights, a lot of flights. One brownout, if you want to call it a brownout, I've ever had in all the flights I've had. Check out the link. It's not a super video, but it's on a run cam and you can see. But most importantly, guys, listen. You will hear the engine stay at RPM. That tells me that I did not have a brownout. That tells me that I lost all power to that receiver. Otherwise it would have returned, if it just lost signal, that thing to idle where it was bound. When it did finally come back, I got it turned around. It's kind of canary for a little bit. I wound up chopping the throttle as soon as I got reception again. Kind of crashed it there. As you can see, crash landed in the field, no damage. And then battery came out, switch came out, threw that stuff away, replaced it. I've flown the plane since multiple times and had absolutely no issues with it. So that's enough flights for me to call this stuff reliable. You can be Ford or Chevy or whatever you want. We got to talk about the elephant in the room and address it. And we got to get through this to help you guys have successful maidens. I've had lots of them. I want to see you guys do well with your flights, keep these things around for a long time. So let's talk about batteries and connections. Number one, we use Velcro. We use straps down here. This is stuff you install in the basement. If you don't believe in Velcro there, that's fine. It's up to you. 2 6S big battery packs, they need to be restrained. If they fall out, it doesn't do you any good. Electrical connectors, I wind up putting a dab of hot glue on every connector to the board. That helps keep them from wiggling out. You can still pull them out with a little bit of force if you wanted to. It doesn't make them so you can't replace it. And then simply you can tack back over it with hot glue again. You could check out other videos that I've done with the AMOS anti-spark. Love those connectors. And let's talk about these dreaded UBECs. The UBEC fried. It's garbage. They were no good. You can test that down in the basement. How do I do that? UBECs, and see the big problem is here is that we think RTF ready to fly or BNF bind and fly. We just throw a battery in it, guys, and they're good. They're not good. It's building complacency. You got to go through the model. That's why I'm going through these checks with you. Check it out before you fly it. So how do I check my UBEC? UBECs are used to power, all right? They're used to put power to the receiver to power your servos. Your servos are what have the load. They have next to no load or current draw at idle. At max deflections, they draw, all right? These things draw some current. When they're fully stalled, they draw even more. So if you can picture a big 3D model, big control surfaces, they're all jammed. The rudder's jammed, ailerons are jammed, you're working that throttle. Those things, big, heavy, powerful servos for those control surfaces, even all that air pushing over them is causing, so when you even put resistance on this control surface, let's go up here, like this, you're increasing that amp draw. So if you want to do a quick check of a bind and fly or an RTF model, start loading all the servos. All right, so we can go ahead and go through the elevator and go through ailerons, so we can work that rudder over and go there and just max control surface, all right, all of these things at the same time. And you can leave them stalled, and if you wanted to, you can even, let me prop you guys up here, you can even put some resistance on these things. So hold them for a little bit, work the UBEC over for a battery pack if you wanted to, Get all those control surfaces moving at the same time and really work that UBEC over. And if you put a little bit of tension on those things and check them out and run through, you know, half a battery or so, you're going to know if that UBEC is going to hold up. So let's talk about what a wiggle test is. A wiggle test I used on my AL to find a loose aileron pin from the factory that wasn't installed in the connector. Before you fly it, go ahead and take everything you're set up, all right, and just go ahead and wiggle your connectors like they would be on the ground or up in the air. You don't want to yank and pull. You want to simulate vibration. So as you go through this stuff, you shouldn't see any of the control surfaces start to jitter or move. And this is what we term as a wiggle test. So wiggle tests are good to help find loose pins. All right. So we have the UBEC done. We have that done. Let's talk about receivers. Placement. Antennas should be 90 degrees from each other, not blocked by carbon fiber, metal, or surrounded by batteries. And it's best to avoid having any of the high power motor wires, battery wires, or anything else running over the receiver, around the receiver. All of these things, and there was a guy that posted on Facebook recently that really did a good job describing a lot of this stuff. Anything that travels, has current travel through it, creates an electromagnetic field. So the more that we can isolate those wires away from the antennas, the better off you are going to be. So we want them at 90 degrees from each other. The more expensive the model, you should think about running satellite receivers. That just helps you have placement, so you're not losing signal, diversity, if you will. So they're run at different altitude or different levels than your receiver at different angles. So that way, depending on where your orientation is in the plane, it will still continue to pick up signal. And signal, again, we're going to talk about making sure, and you'll see in one of the later clips, how to do a range test. Super important before you fly a model. If you notice you're getting a lot of fades, so what's a lot? 1, 2, 100, not so bad. You're getting thousands or tens of thousands of fades. That means one of the antennas is losing signal. Try changing the direction of your antennas or where they're placed, or at even the position of your receiver as far as higher or lower if it's one you installed. If it's in a bind and fly model, they're usually pretty good where they are and tested there, so it makes them more reliable. So we've covered wiggle tests, we covered placement. Antennas 90 degrees from each other, away from battery, metals, and other wires that draw a lot of current. We talk about satellites. So with the UBECs, most of them are already predetermined. If you are going to do a custom setup and know, hey, how big of a UBEC do I need? A 5 amp, 8 amp, whatever. The bigger the servos, if you're running a UBEC, you're going to need a bigger UBEC if they're bigger, more powerful servos. Something to keep in mind, the only way you're really going to know is to go ahead and get an ammeter. So whether it's an inductive for small milliamp current ammeter, which are somewhat expensive, or you can just get an inline ammeter, which you could probably even wire connectors in yourself, is just another option. You need to know what those the current flow is through them servos, and keep in mind you need cushion, because if you stall them, if you're that type of 3D flyer under, you know, high speed, even though these control surfaces are small, they will still be fairly loaded at 100-mile-an-hour pass when you go ahead and pull full elevator to climb and do different maneuvers like that. So something to keep in mind with your UBECs. So there we got UBECs covered. Let's talk about, I had a servo. On my first flight, my servo died. There's ways to prevent that. They sell these servo testers on Amazon. You could get 3 of them for like $5. They're like next to nothing. And you can use a simple NiCad to power these things up. We'll go ahead and plug that in here. And the nice part about this, I use this because you can click the button and you can actually set neutral when you build planes. So when you build planes, you can power up the servo through the neutral function, and then you know where to install all your control surfaces because that's neutral. The next thing we can do is we can go to auto, and we can click the button in the auto mode, and it's going to cycle. So if your hinges are fairly broken in before you go to fly, the servos will draw less current. If you're not big into doing that and you're afraid of max deflection breaking the flap, you can go and we'll click the button again, and you can go into just simple manual, and all I'm doing is moving that knob myself. But you can go ahead and just sit here and do this and work each servo. if I pay $700, $800 for a plane, it's not a bad idea to check it out. I know all the manufacturer ought to assume everything's perfect, but again, I can't tell you that I've honestly had servos fail, like fail installing them. Maybe at one point I had a high-tech somewhere die, but that was for a bigger plane. But I haven't had any of these ARFs, ready-to-fly version stuff. I should call them more ready-to-fly versions. I haven't had a servo fail in any of those. I had some with slop and stuff like that that I didn't like, but I've had no outright failures. We check balance. So everything with CG, almost every one of my planes, I use just little felt Velcro pads, and I put the soft side there so it's nice to touch. But I get either white ones or black ones, and I just stick them to the bottom of my plane. It is a feel reference when you're checking. So if I'm going to run a different pack, because I can vary packs in most of my EDF stuff, if I'm going to vary a pack, I know I can just easily recheck the CG to make sure that it's balanced, but here is the place to do it before it ever makes its way out to the field. So we can address, as you see, a lot of issues right down here. We can kind of load UBECs. We can make sure our receiver placement's right. We can test servos, flaps, anything that's a surface, especially on an EDF. I'm going to go ahead and I'm going to put Blendaderm tape in there. Why? If the thing has a foam hinge, Blendaderm tape will help hinges from failing down the road. If you want to protect the paint on some of these, go ahead and use the Minwax. Cover them over. They got matte for your warbirds, so it doesn't make them glossy. If you like pretty shiny things, you can go glossy. Helps to protect the paint on these. But otherwise, it's just going to be about pre-flight checks, guys. Check out the rest of these things that's going to follow this. This is just some simple checks that you can do down in the basement to be successful. I'll show you some of the ones out at the field. And again, I just want to help you guys. Let's get over the fact that not everything is a failure that we buy. Sometimes we can correct and find issues before we have the unsuccessful maiden. I'd rather replace a servo or a UBEC that I found here than have to try and complain to somebody and hopefully get them to cover it under warranty when I've flown it and crashed it. So again, I'm Brendan here at Just Plain Crazy. If you like it, comment, share the stuff, subscribe. Make sure you click all on the bell notification. Hey, if you don't like my videos, completely cool too. Do me a favor, hit the unlike button or the dislike button twice. We'll catch you guys at the field. Peace out. All right, guys, so we're out at the field and we're going to talk about the pre-flight checks that we do here at the field before we fly. Realistically, it should be done every time before you fly, but at the very least before you fly for the day. And just like Full Scale goes ahead and they have a pre-flight checklist and they do the check over on their planes too. So a lot of the things that we have happen, we could simply avoid by doing better pre-flight. So let's talk about what some of those things are on an EDF or foam model. And I blame a lot of this on the BNF or RTF or bind and fly, ready to fly, and people just assume I'm going to throw battery in it and it's fine, and that's where a lot of the problems come in. So we still need to check these things out better, and I think most of your models will live a better life for it. So one of the first things we want to do is we're going to make sure that we have Hawk selected here so we have the right model. We'll throw this down over the top. We have our battery installed. And this plane, victim to my own complacency, one of the things that we want to do is use a simple battery checker. And we're going to make sure that we have a good battery in there. So we're at 99%. So we have a fully charged battery. We're going to make sure that the battery is firmly attached in the inside. It's positioned with Velcro. Your antennas for your receiver are firmly attached. So I have one that runs this way and then the other one that runs up. We're going to go ahead and I prefer AMOS connectors with mine. We've talked about that in other videos. Plug the ground in first. Second, we'll do power. We'll let this aircraft power up. I like to secure those connectors in on the side so that way they're not going anywhere. Grab this canopy. Make sure that that thing latches. It's in there nice and sturdy. Now let's check the control surfaces. So the control surfaces you want to give a nice tug to if they're hinged. Sometimes the hinges will pull out of the pockets. Same things with flaps. And you're going to go over all your control surfaces. Make sure that you give them a good tug. There's a lot of forces on those things in flight. We're going to check those. check the rudder. And now we're going to take a look at linkages. Sometimes they have those little snap linkages here. You want to check those. Also having a pocket screwdriver with you. On the EDFs, if you haven't seen it, these are just little screws in plastic. They do back out. Take a look at those things and check them. You want to make sure that you pull on the horns and that the horns don't want to come loose. We've seen those pop out already. And while I'm up here, we're going to do the pre-flight on control surfaces. So right, like to do it on high rates. Right, aileron is up. Left, aileron is down on the right side control. And then we're going to go left. So left is up and the right side is down. On rudder, make sure we got left and right. And then for elevators, we're going to make sure that we have that up elevator, down elevator control, and everything there works appropriately. If you do have multi-EDF fan units, you want to make sure that you power those things on and that you have actual thrust out of both of the EDFs. There's nothing worse than finding out that you had one bad EDF unit and you missed it, and you're only going to find out on takeoff when the thing barely has enough power to get going. On the bottom side, we're going to turn this thing over and we're going to make sure that all of our linkages here, there's no stress, cracking. If they're not hinged control surfaces, again, you want to check them for cracking, splitting, tearing. Check all those cracks in the clevises. Make sure your horns are hooked up. All right. And we're going to get down here. We're going to do the same. And again, pocket screwdriver. And we're just going to go ahead and check those screws. Make sure everything is tight. And again, this is something that you can have take a couple minutes and it will absolutely save planes. And we tend to beat these things up worse with hanger rash, getting them in and out of the vehicles than anything. So also checking to make sure you didn't crack wings. If you have wing bolts, these wing bolts never come out, but a good idea to check the wing bolts to make sure they're also secure. And the last thing we're going to do down here is we are going to do a gear check. We're going to make sure that the gear works in and out appropriately. And then you could also check the steering there. So we're going to put the radio down. We're going to take this thing, we're going to flip it over. Now the last thing, you don't have to do this every time, but the last thing I want to talk to you guys about is range checking and what range checking is and what it means. So I am going to go into my range checking function here. And you'll notice it says full power. You want to hold the radio in an upright position. You want the plane to be on a level surface. You don't want it having hills. You have to picture the signal coming out of this radio like an apple, shaped like an apple, the way it comes out. So if I walk with this thing pointed here, it's actually not going to have great signal. And what I'm really concerned with is not so much the F, which is fades, it's the H, which is holds. So we're going to hold in this button here, the bind button. Hopefully you guys can see that. It says reduce power, and I'm going to walk 30 paces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30. And you notice, hopefully you guys can see that, we're going to have some fades. I don't want any holds. You can see my plane is a good bit down there. Again, I want to hold my radio out to my side like this. And what I want to do is basically just check to see, do I have control or no control? A lot of people use this as a go, no-go gauge. As long as I have full control and nothing is glitching or jittering, you're good to go with your range check. If you have a really high fade count, that's telling you that maybe you want to go ahead and adjust your receiver antennas or the receiver position. You might have put a bigger battery in there. It might be restricting some of that signal. It might be up against something metal. It might be up against something vibrating. All the things that we shouldn't do. The antennas may be flopping around against power leads. You want to secure them with tape off to the side, but a range check is absolutely important. One time after setup is absolutely okay. Wiper. So one time for the range check is okay, but a lot of people neglect it, and then they get up in the air and go, oh, spectrum this, spectrum that. I have a lot of stuff I fly with orange receivers and have no problem. Nonetheless, everything spectrum on 2.4. And that includes stuff from $200 up to $3,000, $4,000. So I think it's really about doing all the right pre-flight checks, making sure that you check over everything that we did. We're going to go ahead and get this thing up in the air, and we're going to get kicked over to a nitro model, nitro wood airplane. For the next segment. So I hope you guys enjoyed the ARF one. We'll catch you in a bit. Channel. Now what we're going to do today is we are going to go through a pre-inspection or pre-flight check on a glow model, and we're going to look at some of the difference as compared to the glow model and compared to what we did in the basement. So let's check this thing out. This is my Piper Pawnee. Some of the things that we want to look at with a glow model. I guess we can start in the front. Best place to start, work our way back. Looking at your prop, make sure nothing is split, frayed, chunked. Make sure it's in good condition, right? The edges, the tips. We want to make sure that it's tight on there, that nothing feels loose. We want to make sure that we have a gap around our spinner and the prop, that it's not touching it. Sometimes by using the electric starters, it tends to either break these or spin these, and it pressures against the prop. That vibration can cause that thing to break. You can check your glow plug using a nice starter like this one. Has a little gauge on there, so literally we can go ahead and we'll hop over here. And as you see in the inside of there, that thing is green, so you know that your glow plug is good. We'll start to look around on the next part, the inside of the plane. If you guys can see in there, I use a filtered clunk at the bottom, and I use see-through tanks. That way you can see that that thing is firmly attached. It's not folded over. You want to make sure that none of your fuel lines leak or are out of place. We want to make sure that, and this one we use satellite receiver there, and then we also use our receiver here. Receiver is firmly mounted. Wires are nice and pushed in. You can see the antennas we talked about in a 90 degree. So this one's in a tube that literally runs back. This one is in the side that runs down. We want to make sure that all of our fittings and connections into the servos are good and tight. The servos are in place. And while we're in here, we are going to use our loaded voltmeter. It's just not a straight voltmeter. And I have a switch mounted right down in there. So we will go ahead and make sure that we check receiver battery in the inside of the plane. And again, this is loaded, so with a load on it, we're still above 6 volts on that scale, which is still good for me. If you were to check this, the nominal or surface voltage would probably be 6.3, 6.4, 6.5, somewhere right in the inside of there. And then if you can also see on the inside, I actually wired in a volt checker. See if we can turn it on. You can actually see that. So it actually has an inside voltmeter, and that is nominal voltage, but it'll go red as it starts to drop off. And this is my bunny pilot, so this is something my daughter gave me, and that's where he wound up. On this thing we have our struts, making sure that all of our clips are there and attached. We're going to make sure that the ends are nice and attached. Again, when it comes to control surfaces, they're some of the most important things, so we are going to give those a good healthy tug. If you have horns, make sure that nothing's peeling up on the other side. Everything's good there. We'll come to the back. We'll do the same thing there. Checking our control wires. Sometimes these little fuel line holders break your rudder. You want to give that thing a good pull. move to the other side, the elevator there and here. So those are just CA hinges, so they can pull, they can break, all kinds of stuff. So fuel lines are good, servos are good, connections are good, receivers good, struts, things up top. Now we'll come down to the bottom of the plane. One of the things that I see happen a lot is landing gear falling off. So we're gonna make sure that we give that thing a nice healthy check right there. And sometimes I'll use, if the axles stick out, I'll use some fuel tubing right on, support this here. I'll use some fuel tubing right on the ends of the axles if they stick out right there for, just so the nuts and collars don't fall off. But again, we're gonna be checking our horns, checking our linkage underneath, make sure nothing has come loose or pop loose. And we're going to do that all the way around. So we're checking the elevator, the rudder, and then we're gonna do the same thing on this side. And you got the fuel line holding that. All the clips are supported. So we're good. And if you guys can see, what I do with all my models is I put those little fuzzy things right there. Those are my CG points. So at any time throughout the course of the day or field, I never need to check CG. If I use a different size battery or change something, I can always find my CG because you got some place to feel it. So we are going to get fuel into this thing. Again, these are some of the easy checks you can do. It just took us 2 minutes, and that's with me explaining everything, to literally go through this plane and feel it's confident to be airworthy and not have any issues. So pre-flight stuff in the basement, pre-flights with foamies, pre-flights with glow and gas. They're all slightly different, but something should be done every time, technically before every flight, but realistically, if we do it before we fly it for the day, you'll be pretty well off, and probably go through a lot less money and a lot less models. So good luck, guys. We'll catch you. All right, guys, for the next part of our series, we're going to actually go through a glow model, and we're going to take a look at that thing, go over some of the touch points on things we ought to be looking at with this plane. Now, this is a Telemaster that was scratch built by my grandfather. He's since passed away many years ago, and this thing was given to me along with a couple of his other models, and I've done some upgrades to it over the years and changed some things around to keep with technology. But ultimately, this plane here, guys, is over 30 years old, and I have quite a few models that are that age that are still flying. So pre-flight on a glow is a little different from the EDFs that we've gone over. So some of the things we're looking for, and the big one is we are going to check receiver voltage with this. I'm using a 5-cell pack on this, and this is actually a old scale voltmeter from Hobby Co. You may still be able to find these, but if you do, they're really good. They don't actually measure the surface charge of the batteries, but they will measure, they put a slight load on them, so it gives you kind of a more accurate idea. So the first thing that we are going to do is we are going to plug into there, and we are going to get a voltage reading, and we're going to check this thing out. So a little bit of load on there. We're still up at 6.4, so we know that our receiver battery's good to fly. So we'll go ahead and we'll close that back up. On the inside, we're going to take a look at all of our servos, our clevises, make sure everything is still there and attached. We have retainers. Anything on this one uses some steering cables, is tight. Throttle linkage is good. As we come up to the front of the engine, take a look over the propeller, make sure that there's no cracks, make sure that there's nothing wrong, chips or anything with the propeller, that the nuts on there nice and tight. You want to make sure that your fuel tubing is in good shape and it's not burnt, all right, not split and not leaking. This is a big one. Check your mufflers. Make sure your muffler isn't loose and ready to fall off, and the pressure vent for the muffler is in good shape. If you have a see-through tank, a lot of the planes I've started using see-through tanks on them, you can actually see the clunk. So it's advisable to give it a shake. Make sure your clunk, you can hear it rattling around in there. As far as the wheels go, check your wheels out. Make sure that the wheels are going to stay on there. I actually use little pieces of fuel tubing over here on the ends as retainers, just to make sure that the wheels don't fall off. Again, same thing as our EDFs. Give the hinges, all the control surfaces, a nice hard pull. Make sure that everything is good there. As we come over to the wing, we're going to do the same thing. We're going to check all of the clevises, check your control horns, make sure that's nothing is loose or cracked. We're going to check over all those hinge points as well as we go down through here. All right, and same thing with the control surfaces in the back. We're going to check those hinges, make sure that we don't see any cracks, clevises aren't loose, none of the linkages are loose, none of the screws have backed out. And short of that, we're going to talk about the rubber bands. So on all of my connection points, I use these little lock connectors here. So let me go ahead and get the aileron hooked up, and we'll talk about some rubber bands. Be right back. So the wing is on. One of the questions you often see people ask is, how many rubber bands? And how you put rubber bands on is very important. So I latch mine together in a double latch. You just basically put one through, loop it through, and pull it. And this is 2 rubber bands that are on there. You always start the first ones this way. So I will literally do, and give these things a good stretch. Like, do not be afraid to stretch those things. You want to know if they're going to fail now before they get up in the air. So I'm going to take 4 of these and put them on. The last ones you crisscross, and basically what this does, again, good pull, is this prevents the inside ones from slipping off. So I do one there, I'll come over here, do another one, latch that on, and again, nice big pull, and over to the other side. So a little bit of an aerobatic plane, nice floater, good flyer. Like I said, this plane is over 30 years old. It's been in the family for a while. And the last thing we're going to do now that the wing is on there, is again, control surface check, just because you never know if anything ever changed. So we have, turn this thing on. We have up elevator, down elevator, left rudder, right aileron, and left aileron. If you're not sure, have somebody check it out for you. And again, we're going to go ahead and make sure our throttle works and it doesn't stick. And for you guys with gas engines, no different than electric, make sure that you have it set up on a throttle cut that will work. So I have mine set up on a switch in the carb. Make sure that when you fire this thing up the first time, that you can hit a switch here and that it's going to kill that throttle. And I have had one instance flying where I've actually needed that thing coming in. Plane was losing reception and went ahead and killed the engine. But anyway, that's the end of our glow segment. I hope you guys enjoyed that. So we have our foam section done and we have our glow section done. Hope you guys enjoyed it. Peace out.